Day 144, Physics, Circuit 1C. Once again, we will apply these principles by drawing new diagrams, keeping in mind that in parallel, all elements have the same voltage, series they have the same current. There's no rule that says you start with the parallel part or the series part. In this case, the 30 and the 10 are in parallel. If you were to draw location here A and B, as I've done before, there are two ways to get from A to B. You can go around through the 30 or straight across through the 10. Most of the current wants to go across the 10, which is a smaller resistance. In fact, 3 times as much current will go from A to B that way as it will around that path, not because it's longer, but because this is least resistive. You could say in this situation the 20 ohm resistor is in series with this combination out here. I'm going to start this problem by combining the 30 and the 10 in parallel by using the 1 over R total rule. I will write that all down and draw the subsequent diagrams. I'm going to pause and it'll show up here in a flash. Alright, so I flashed this all forward. Bottom line is my first move was to combine the 30 and the 10 that are in parallel by using the 1 over R total rule. So combined, the 30 and the 10 become 7.5 ohms. So I draw my new diagram right here. The 20 is still over here kind of by the battery. This spot right here would be point A. I guess I can label that again. I'll use a different color. This is point A. This is point B. And I have replaced the 30 and the 10 with the 7.5. So the 7.5 is connected from point A to point B, which were over here in red. The 7.5 is equivalent to a 10 and 30 in parallel. And then I drew the final diagram because the 20 and the 7.5 are in a series. So it's just simple 20 plus 7 is 27. So here's my final diagram. So the rule in these problems is, or the guideline is, to draw these diagrams, get to the last diagram, and then apply Ohm's law, this V equals IR. So I'll go back to that. In this final diagram, I will now apply V equals IR. V is 100. I'm looking for the current. Resistance is 27.5. So the current is 3 point something. It's 3.6 amps. Right, so that's the current that's flowing in this simplified circuit. I can represent that with an arrow. It starts everywhere, not at the battery, but that would be 3.6 amps of flow, coulombs per second, in that circuit. Well, if I go to the middle diagram here now, that's the same current still flowing. It's still one loop. In other words, each of those resistors, which are in series, follow the series guideline. That is, they have the same current. They both have 3.6 amps of current. They do not have the same voltage. They're not 100 volts. In series, you have the same current, not necessarily the same voltage. I'm going to calculate the voltage using my V rule, my Ohm's law, V equals IR. So, for example, for the 20 ohm resistor, V20 equals I20 R20. So I will calculate the voltage. The current is 3.6 amps and 20 ohms of resistance. So the voltage is what, 72 volts? 72 volts. All right, and then for the 7.5 ohm resistor, I'll have V for the 7.5 equals I times R. That's all for the 7.5 ohm resistor. I'm looking for V. Its current is 3.6 times its resistance, 7.5. Sorry about this, I'm in a lot of space. But if you do the math here, the voltage for the 7.5 ohm resistor, that's the subscript, 7.5 ohm resistor, comes out to be 27. In a perfect world, that would have been 28 because the 27 plus this 27 plus the 72 should be 100. It's 99, so it's real close. Things when you round off to 2 sig figs, they're not exact, but that's a guideline that shows me that I'm in the right path here. but they have voltages that add up to 100. Their currents are both 3.6 amps. So once again, I'm just using V equals IR as I work my way backwards. Now let's go to the original diagram over here. So what I know, if I draw some arrows here, that there's from here around this way, that's my 3.6 amps. The battery is delivering 3.6 amps of current from, well, pushing it from B to A, 3.6 amps. But when it gets to point A, it splits. Some current goes across here. In fact, most of it goes there. Some of it goes around the top. The question is how much goes? Well, you figure it out by V equals IR. The question is, well, let me write this down. Pick a resistor, the 10 or the 30. I'll start with the 10. So V sub 10 equals I sub 10, R10. I know its resistance is 10. I'm looking for I, but what is the voltage of the 10 ohm resistor? Well, it's not 100. Here's the trickiest part maybe of all. The voltage for this resistor, this 10 ohm resistor, is the same as the voltage for this resistor, which is its replacement. And that was, the 7.5 ohm resistor was 27 volts. In other words, I know that each of these resistors, let's use green, is 27 volts. This resistor is 27 volts. This resistor is 27 volts. I know that in parallel they have the same voltage. They have the same voltage as their replacement way over here on the right, on the middle diagram, 27 volts. That's maybe the trickiest move in this entire process, right there. 27 volts, not 100. If the 20 ohm resistor was not there, then it would be 100 volts, but they're not. The 20 ohm resistor is there, so they have the same voltage as each other, but not as the same as the battery. So now I plug in for the 10 ohm resistor, it's 27 volts. Down here, lower left, I'm filling it on the lower left here now. I'm looking for the current. Its resistance is 10, so the current in that resistor is 2.7 amps. And I can do the same thing for the 30 ohm resistor. Let's use, well, I'll use black. So V30 equals I30 R30. Everything for the 30 ohm resistor. It's 27 volts, same as the 10 ohm resistor. In parallel, you have the same voltage. So we have I30, which is what I'm looking for, times 30. So the current in that resistor is basically 1/3 of what it is in the 10 ohm resistor. It's 0.9 amps. So all these circles that I have down here now can be filled into the chart. We've got to be careful though. So we just figured out the 10 ohm resistor. The 10 ohm resistor, the current was 2.7 amps. I'm going back up to this chart here now. Its voltage was 27 volts. Well, let's do the 30 ohm resistor. The 30 ohm resistor, sorry, I'm skipping around here. The 20 ohm resistor, looking down here below, the 20 ohm resistor has 3.6 amps of current. It's by the battery. It's a 3.6 amps. Its voltage for the 20 ohm resistor was 72. That's down in green at the bottom there, 72. The 30 ohm resistor, it has, that was the last thing I calculated with the black, down at the bottom in black, was 0.9 amps of current. It had the same voltage as the 10 ohm resistor, 27 volts. The battery was pushing 3.6 amps of current, same as the 20 ohm resistor, because the 20 ohm resistor is basically in series with the battery. Its voltage is 100 volts. And now we can calculate the last column. The last column you can calculate by using the equation, and I'll just point it out. You're using this equation up here on the left, upper left here. I'm circling it. P equals VI. You're gonna multiply this times this to get the last column, the power. I'll do all of that. Actually, you could probably do that. Well, I'll do it. I'll multiply this number times this number in all four cases. All right, so I've computed all those numbers. This is the power, the wattage of the bulb. I'll circle it in green. Those three numbers should add up to 360. It's close. They add up to 356 because the battery supplies the energy, the power, 360 joules of energy per second. And the light bulbs, the resistors, are turning it into lighter heat at a rate of 356 rounded off to 360. So it checks out, and there we go.